Hello everybody, it's Mr. Canfield for another Algebra 1 lesson 3-2, our assignment today. So remember, I call these assignments because I'm taking lesson and assignment, squishing them together. If you go in, find the 3-2 assignment, get your notes. Remember, you're allowed to use notes on your tests and quizzes, so you should take good notes. You should have good stuff written down so that you can go back and look at it. And we're going to go through, we're going to do this assignment. We're going to figure out how to do these questions. We're going to learn some new words. We're going to learn some new terms. We're going to go through problems maybe that we haven't seen before, but that's the whole point. We're going to learn as we go. And anytime you learn something new, make sure you write something down. And remember, there's a big pause button that you can use, and you can rewind, and you can also email me anytime. You can always ask me questions. So don't take this as, here's the video. That's it. You're done. Make sure that you ask me questions if you have them. Okay, let's go. So this topic is all about something called functions, and we're going to learn what functions are, specifically linear functions. So last time we talked about the vertical line test and the idea that one input gets one output, and as long as there's only a single crossing or even no crossings with these vertical lines, then we're good. So let's see what our first question is today. Describe and correct the error a student made when finding the function rule for the data in the table. So we're trying to find some rule for this function. So if we go in here, I'm going to do some screen grabs today. All right, let's try to figure out the rule. A great way to figure out the rule is to figure out the difference between successive terms, which is a fancy way of saying, how much does it take to get from 1 to 2? Oh, it takes 1, right? We went up 1, so I'm doing plus 1. What about from 2 to 3? Plus 1. 3 to 4, plus 1. 10 to 19. So if you're having a hard time doing this, you can do 19 minus 10, and that'll help you figure out that it goes plus 9. What about here? 28 minus 19. That's another plus 9. And then 28 to 37, so 37 minus 28, that's another plus 9. So we don't care necessarily about the individual numbers. Now, in this case, you might notice it's the same each time. We go up 1 in the x, or I guess over 1 in the x, and up 9 in the y. So this is actually how we can find slope, because secretly we just did y2 minus y1 and x2 minus x1. So all you have to do is put the y1 on top, or the y answer on top. So the 9, positive 9 divided by positive 1. What's 9 divided by 1? It's 9. So if I'm looking at some y equals mx plus b equation, remember the slope, what we just found there, that's part of this equation. Y equals 9x. Now we just have to find b, and I'm actually going to show you a special trick to find b in just a minute. This person who did this problem is actually very, very close. They said it was y equals 9x plus 10. So what they said was, oh, this first thing that we see, the first thing that we see is always going to be the y-intercept. And you might have that belief too, that these two things always match. That is not actually true. That's only true when x is 0. So if you recall back to last chapter, we talked about something called a y-intercept. And a y-intercept happens when x is 0. The cool thing is a problem like this is super easy to go back to 0. There's a pattern here, right? From 1 to 2, 2 to 3, 3 to 4. We're going by 1, by 1, by 1, by 1. Can't we just do the same thing? Right? 0 plus 1 gets me 1. So what would belong here so that when I add 9 to it, I get to 10? So you just do 10. You could take away what that common difference is there, that 9, and get that 1 is there. So if you look down here, it says the student should have used x equals 0 to find the constant term, or constant term is what we would use for y-intercept, not x equals 1. When x equals 0, y is equal to 1 in my problem. The correct function rule is y is equal to 9x plus 1. So this technique, there's a couple of things that we did here, but we took the y number divided by the x number, and that was our slope. And then b, oh, that's a very big highlighter arrow. Maybe I can use a finer, there we go. When x is 0, y is whatever the y-intercept is. So I wonder if, try again. It's the same question. Cool. Oh, they switch around the answers. Oh, they sure tricked me. Whew. I've learned that when you try again, if you don't get the correct answer, if you don't go in and get the correct answer, it'll say you didn't do it in the final when you go to turn it in. I don't like that. All right. So next. Whoa, okay. What in the what? Or should I say, what in the okay now? Or what in the is this? What the mess is this? Is that the channel FX? Is that, what, Let's talk about how to pronounce this. This is a special notation. It's called function notation. And the way that we read this is f of x. So we are looking at some function of x. Now, the reason that we're learning this is going to be more apparent the higher up you get in math. But this right here, this is actually a synonym for something else. You've actually seen stuff like this all over the place before. There. It actually means the same thing as this. And you might be like, Mr. Canfield, we've been using y. Why are we now using this f of x business? Don't call it fx. That's a TV channel. Call it f of x. It doesn't mean f times x. F is the label that we use, and it stands for function. So the reason we learn this is because mathematicians love to abbreviate. Instead of using words, we like to use symbols as much as we can. It takes up less space. It's more efficient in our writing. So the reason we use f of x is instead of having to write this, what is y? Wow. What is y when x equals -6? Instead of having to write all of this, mathematicians, oh no, I did the thing again. I did this in the video last time too. I have to like click away from, oh boy. Okay. So instead of having to write what is y when x equals -6, instead of having to write that, we can actually write this. And this right here is the exact same thing as that entire sentence right there. So anytime you see like f parentheses a number, it's really saying what is y when x equals that number. And for a problem like this, it's really just a matter of substitution. So it says, it's really just saying, hey, what's f of -6? You take this side of the equation, and you accidentally use the wrong tool, and you go 9 minus 8, and we're going to plug in -6 for x. So let's say you're struggling with, you know what that is. Well, let me just pull up my Oops, wrong one. Here we go. All right. Just resetting the memory. Okay. So 9 minus 8 parentheses negative 6. Close the parentheses. Boop. I got 57. You can literally go to your calculator and you can type it in. It'll do it for you if you're struggling at all with any of the arithmetic. So what about f parentheses 0? Well, remember, that just means f of 0. That's how we pronounce it, sorry. And all you have to do there is take this same thing again, but instead of x, we're going to plug in 0 where x used to be. 9 minus 8 times 0. So if we do the order of operations, we do the 8 times 0 first, and that's 0. So 9 minus 0, we should just get 9. But again, we can go to our calculator and we can type this in. All right, I was trying to use my keyboard. It only does so much. I'm on my computer, not my actual calculator. This is a virtual calculator. All right, so yeah, I got 9, just like I said. And then, oh, I see f of 5. Hey, guess what? All you gotta do, take this 9 minus 8x, anywhere you see an x, rip it out, and drop the 5 in its place. Wow! No, all right, sorry. So 8 times 5 is 40, so 9 minus 40, I got negative 31. And again, I'm doing this over and over again on the calculator because I want to assure you that there is nothing wrong with double checking these things in the calculator or just having the calculator do it for you. Hooray! So cool. That I just plug stuff in. That's not hard. Correct, it's not. And let's talk about one of the benefits of f of x. Here's a benefit. Let's say we have f of x, but there's another function that we want to talk about for some reason, and we can call that one g of x. Now, all of a sudden, what is y when x is equal to negative 6? Wait, for which one? Oh, for f of x. Well, then you have to go back in, for the first one. You have to go in and you have to say even more words now to try to have to do that. Or you can just say f of negative 6. And then what if you wanted to plug something into g of x instead? Well, then you have to go and be like, well, for the second one, when x is equal to 2, what's y equal to? Instead, you can just write, hey, what's g parentheses 2? And you go, oh, I go to g and I plug in 2. That's all this means. So don't get freaked out by the notation. If it ever helps you, you can go in and you can kind of scribble a big Y over it. A lot of my students in the past do that to kind of stop themselves from getting tripped up on it because it's not a big deal and it doesn't need to be a big deal. So like this one, this looks like it might be a big mess, but it just says f of 3. It just means plug in 3 to the stuff on the right. That's all it means. So let's see. I don't even need to pay attention to the left-hand side. In all honesty, I just need to pay attention to this. And I would recommend, I definitely would challenge yourself and try to do the order of operations. Try to get this correct by hand. It's worthwhile to put ourselves through that mental exercise. But if you don't, that's okay. So it says, oh, I could zoom in just a little bit more. Yeah, I can do that. Okay. It says f of 3. So I want to plug in 3 where x used to be, and now I'll do the order of operations. Please eat my Domino's and Subway. I don't know. All right. So let's see. Parentheses. So I look inside here, I do the order of operations inside here. The only thing I see is plus, so -5 stays outside. The 3 plus 3 turns into a 6. Now, this is a -5 touching a parentheses. That is secretly multiply. All right, it's -5 times 6. So I don't see any exponents. Now I'm on the multiplication division step. So -5 times 6 is -30, because a negative times a positive makes it negative. If you are like, wait, it's literally just plugging stuff in. Yeah, it totally is. Seriously, that's all it is. All right, let's see what's next. That was the previous version of the video right there. I started filming the video and I started the assignment, and there were 25 questions here, and I had already edited this down to 12, and I was like, wait, why is it showing all of them? So I actually go into the textbook, I rip out problems that aren't useful for our class, and I try to make the lessons a little bit shorter and more digestible. And I'm sorry if you can hear the little burping. I'm trying to do it under my breath. Speaking of digestible, lunch must not be agreeing with me. Mrs. Canfield was like, hey, you should go out and get Taco Bell. Because I was like, I want bad food. And she was like, go get Taco Bell. And I was like, okay. Actually, no, she said McDonald's. And I was like, I want Taco Bell. So I now regret it, but I do love some Taco Bell. Especially things like chalupas and stuff that I have no business putting in my body. All right, so this one says f of a is equal to 3 parentheses a plus 4, close the parentheses, minus 7. Okay, this is interesting. It's using a different letter. In case you haven't figured it out, or you're like, oh no, this is going to be so different. No, it's the same. It's the same as if it was x. The important thing is that those are the same letter. As long as those two things are the same letter, as long as it's the same letter on the left and the right, there's nothing weird about these. It's just saying this one is a function of a. As a changes, stuff happens. So this time it says, what's f of 5? So when I plug in 5 for a, when I just go here and drop a 5 in, and if I was doing a worksheet, I might actually write that in the, like, problem number 2 says this. I might actually go in and just scribble a 5 over where the a is and start my work after that. Let's see, so the 3 is there. 5 plus 4 is 9. That's inside the parentheses. That's why I did that first. So now, if I'm doing please excuse my dear Aunt Sally, I have to do multiplication before I do subtraction. So I do 3 times 9, I get 27, minus 7, I get 20. I want to see if I'm right before I do this in my calculator. Okay, cool. So check this out. I can actually go to my calculator and I can type in the original step and it will do all the work for me. If you didn't know that, these calculators can do please excuse my dear Aunt Sally perfectly. The problem is if you make a typo or you type something incorrectly, it's not going to know that you're incorrect in the way that you typed it, and it might give you a wrong answer. So what I just did is it's a very classic confusing thing that happens to people. We have 2 negative signs on our calculator. I know it's kind of silly because we as humans, we use something called context. So like when we look at this, we go, oh, you're subtracting 7 at the end. The calculator does not know the difference. The calculator doesn't understand that this top one is what we would write if we're trying to write minus 7, and the bottom one, we should just be subtracting the 7. What the calculator actually did was instead of subtracting 7 at the end, it actually multiplied by a negative 7. So it took 3 times 5 plus 4, then it did times negative 7. So the calculator is being a little bit silly with that, and that's why we want to make sure that we're careful when we're typing things in, and we don't want to solely rely on the calculator to think for us, because it's just going to do the work. It doesn't always know what it's doing. All right. So now we have the, spinning dots. Cool, next one. Evaluate f of x at the given values of x. All right, so for some reason, they're bringing in different ways to look at this and write it, which is totally fine. We can do that. Maybe I'll just be a little lazy here. Copy, paste. All right. So there, I saved myself 3 seconds. So what? Oh, it's asking for the value of f of x for x is equal to -5 is, if you're like, do I just plug it in? Yes. So 3 parentheses -5, right? Which is 3 times -5, which is -15. Wow. Wait, there's another part of the problem. Yeah, because this one, it gave me that x value, and then it also wants to know, hey, what's y when x is 3? So, are you serious? Just do 3 times 3, it's 9? It must be more complicated than this. Here, much, much more complicated. Yes. Yes, now we have complicated questions. Yes, be very confused. Ha 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 ha. I'm just kidding. We'll take care of this one. Let's just grab the function, but we'll kind of talk through the whole thing. Woo! All right, got that aspect ratio messed up a little bit. That's a little bit better. Okay. So this time we have f of x is equal to 7x minus 18 all over 4. If 7 is an element in the domain of f of x, what is the corresponding element in the range? Wait, domain. Wait, what letter went with domain? This is where I'm doing like the children's television thing. We're like, hey kids, do you see the number 5? And the kids at home are supposed to be like, it's right there. And like the fake kids in the TV show are like, it's right there. And they're like, good job, kids at home. So this is where I'm like, hey, 7's an element of domain. Wait, what letter's domain? And I'm like looking at you, like expecting that you're going to remember from last time that domain is X. Wait, 7 is X. Corresponding element in the range. My wife's calling me. I should mute the video. Let's see. Hello? And we're back. Okay, so 7 is just X, and then element in the range just means Y. So all it's saying is when X is 7, what's Y? So you literally, when X is 7, what's Y? So you might need to do this in 2 steps in your calculator, because we have the top, and then it's all divided by 4. Boom. Divided by 4. Ew, 7.75. I don't think it's going to take this answer. Oh, okay. It took it. I was figuring they were going to have us do math, enter, and turn it into a fraction. All right. So, but let's say instead of doing this in 2 steps in our calculator, you want to do it in 1. Check it out. If you open up a parentheses, then type the whole top, divided by, open up a parentheses, type the whole bottom. So I opened it up, typed the whole top, closed it. Divided, opened it up, write the whole bottom, closed it. Boom, does it all at once for you. Oh, snap. All right. Next, I just plug it in. It's more of the same. All right, now we got something different. Use the table below to determine whether f of x could represent a linear function. If it could, write f of x in the form of y equals mx plus b. All right. So let's see if we can make a y equals mx plus b equation out of this. All right, so Weird. I meant to be using this, but I'll stick to this for now. So 0 to 1 is 1, 1 to 2 is 1, 2 to 3 is 1. Okay. I am doing something here, I promise. Let's see, negative 2 to 1. Ooh, negative 2. If I was on a number line, those are actually 3 apart. 1 to 4 is 3 apart. 4 to 7 is 3 apart. If we ever get a slope that isn't the same between two of these, then it's not linear. A linear equation always has the same slope between each one. Now, that could mean instead of being 1 and 3, 1 and 3, 1 and 3, I could have 2, but then the bottom would be different as well. The bottom would be 6. All right, so, but in this case, we just have 1, 1, 1, 3 through 3, so great. Then we know that the slope is when we do the, oh, this says f of x. Remember, that's the same thing as y. You just do the y stuff divided by the x stuff. It's 3 over 1, so our slope is just 3. So I already know that I can write this as y is equal to 3x plus, and I just need to travel back until I hit 0. Oh, wait. There's 0. So I can write 3x plus negative 2, but I need to write, instead of plus negative 2, they're going to get mad at me if I do that, I think. Oh, they're fine with it. What? Oh, cool. I'll take that. You could also write 3x minus 2. All right, let me make sure I'm recording. I've had to interrupt a few times. Cool, I am. All right. Almost done. So more of the same. Cool, we got a couple more things to do. A couple more ideas, but we've basically covered everything. I'm just going to go into some details and make sure that things are clear. Yep, cool. So we will do that, and this lesson will be over. All right, so on this next one, it's the same kind of problem as number 8. We are looking at this trying to say, okay, is it a function? Not is it a function. Is it a linear function? So again, we're going to try to find the slope of it and see if it has a consistent slope. So oh, it's not going by ones this time. But let's see if, all right, negative 2 to 0, well, that's going up by 2. 0 to 2 is going by 2. 2 to 4 is going by 2. Oh, it's going by 2s this time. That's okay. Then, wait, it's not 7 up to, it's not going up this time. This time it's going down. It's going down 5. So what about from 2 to negative 3? If it's going a different number, then this is not a linear relationship. It has to go down the same, it has to go down negative 5 again. Yes, it is.
That was your...
Yeah, it's fine. Then negative 3 to negative 8, again, going down by 5. Cool. So remember that the way that we write our slope with this is we do the y's on top. So I got negative 5 over 2. Well, that's a silly looking 2. So we'd say this is y is equal to negative 5 halves x. And then if I knew what it was when it was 0, which we do, it's right there. Sweet. You say plus 2. So I wrote negative, and then I typed 5, and then I typed divided by 2. It just did it for me. You can also use a little fraction-y thing here. So I type negative, and then click the fraction-y thing. 5, 2. Hopefully you figured that out by this point in the year. Do you need a hand? And let's see if we're right. And then I gotta pause the video again. All right. 10, 11, 12. 3 more problems. All right. Is the function shown a linear function? Well, look at those. Are they in a straight line? If they're in a straight line, we can call it linear. Sometimes when I get this problem, they're not in a straight line. All right, so we are looking for the y values to change by a constant amount for every unit increase in x values. That's a kind of mathy way to talk about it. Also, the points on the graph can be connected by a line. The function is a linear function. Woo! Let's look at another one, though. Oh, there's more. Oh, the domain. Oh, domain. Oh, fun. I have to talk about domain now. Remember, domain's all the x values, right? Well, let's talk about the domain. It's just the x values, so it's not any of the in-betweens. So I can't just say it's -2 all the way up to 1.5. I have to go, it's -2, comma. Oh, that's -1 there. That means this is -1.5, comma, -1. And it looks like looks like it's just going to be every number between there. And then it stops. So it should be that. All right. And I got to do the range now. Well, range is the same thing. It's just the y values, right? So I just go in, and this question is long and involved. Oh, it looks like the y values are also going by 0.5s. So again, the way that I'm finding these is by looking at the points as I go along and go, hey, what's the y value of each of these points? And I just write them down. Then let's see. So I'm at -0.5 here. So we got 0 and then 0.5. All right. Whew, that's an intense question. So I'm going to click similar question. Oh, that's linear as well. I swear I saw one where it wasn't linear. That's what made me click that question because I wanted to use it. Oh well. All right, we got a couple more involved questions, but here we go. A snack bar at an outdoor fair is open from 10 a.m. to 5:30 p.m. and has 468 bottles of water for sale. Sales average 1.3 bottles of water per minute. I wonder, well, 1.3 bottles of water per minute, how many is that per hour then? 78 bottles per hour. I just think that might be important. Oh, it is. See how in the graphs down here we see hours, so that's going to be important. So if we start with 468 bottles, how many do we have after the first hour? 390. So if I'm starting out at 468, that's not this one. It's going to be one of these two. And after 1 hour, we're down to 390. So after 1 hour, we should be around 400. So that tells me this is going to be our graph. The domain of the function is the set. Are you serious? Okay. So I got to go through and type in each of these. Thankfully, they have it on there. When do we run out? Let's see. 0, 1 hour, 2 hour, 3 hour, 4 hours, 5 hours, 6 hours. All right. The range. Oh, well, it's going to be a little hard to get just from the picture. So doing this is going to be important. All right, so we're going down by 78. So 390. Oops, a daisy. Didn't click on it. 390. And then minus 78. See how it says ANS minus 78? If I click enter and then enter, it'll just keep on doing it. 312, 234. 156. Well, that's convenient, isn't it? That they perfectly run out. Oh wait, they said that that's the average. This is a graph of the average. At this rate, the snack bar would run out of water at 6 hours. So 6 hours, when did we start? We started at 10 a.m. So, do I have a clock on here? No, but if you think about that, 10, 11, the way that I do time is I say that, so that's our 0, right? And 1, 2, 3, 4, 5, 6 hours. I just kind of count. So 10 is 0, and then 1, 2, 3, 4, 5, 6. So 4 o'clock p.m. All right. Oh, it's still going. The snack bar is open for, how long is that open? Well, the way that you can do that was from 12 to 5:30, we could say it's 5.5 hours a day, right? And there's 2 more hours before it, so 7.5 hours or 7.5 hours a day. Sales average 1.3 bottles per minute, or, we already figured this out, 78 bottles per hour, right? Is that what we figured out? Yeah. This means that blank bottles of water would be sold while the snack bar is open. So if all I have to do is 7.5 hours times the 78 bottles per hour, 585 is if they had enough, that's how much they would sell. So, all right, and our last question. Determine a linear function from the data in the table. Identify a point that is not part of the function. All right, so we're just trying to figure out, do any of these not wind up on the line that happens from these 5 points? The problem is we don't know what the line is. So what I can do, let's figure this out. Well, these are going by ones. The x's are going by ones. That's simple. What are the y's doing? 180 to 174. Oh, wait, I thought I clicked on you. So that's going down by 6. Then 174 to 168, that's going down by 6. Okay, so it's going down by 6 every time. So I could say this is y is equal to negative 6x. I just need to find out when x is 0. Oh, 180 plus 180. Cool. So the annoying way to do this would be to continue this table 5, 6, 7, 8 and go for as far as we need to get to 21, negative 15, or we'd have to go backwards for negative 15, 12, 30, and 9. That's too much work. Instead, what I can do is I can go to my calculator. I can use this function that I made here. I can say negative 6. Which one of these is x? The first one is. So I should just be able to type that. And then if I get the y value, then it works. It says which one is not part of the function. So what I'm going to do is I'm going to go up here and click enter. It's going to copy paste it. Negative 15. Oh, guess I got to re-add this in anyway. 270. All right, that one worked. 12. 12. Oh, there's an extra number here. I can hit delete and it'll get rid of that. 108. That worked. I don't know. Are they all going to work? If it's the last one, oh, is it going to be the last one? Are you serial? Super serial. 126. It's only 120. Yep, wrong. So a little obnoxious, but that's how we do it. So I hope this video was helpful. Sorry for the start and stop nature of it. Sometimes life happens. You got to do stuff. But yeah, just let me know if you have any questions about it. And to the 7 of you that are consistently doing my assignments. Thank you for your continued effort and participation in my class. No, just kidding. Most of you are doing your work eventually. Just, yeah, hope you're learning. That's the main thing I care about. Have a great day, everybody. Bye.